All right, folks, this video is going to be super short. I just need to introduce you to the programming task associated with lesson 4. It's all about data flow. To put it real simply, your task is basically just to implement a data flow analysis and to convince yourself that it works using tests as usual. So the difference between this and the previous task is that this isn't a transformation on programs. You just have to implement analyses. So for example, you are free to implement any of the analyses that we saw in the previous video that are also listed in the notes associated with this. You can even just implement the real simple reaching definitions analysis that we used in an example. You just have to implement one of them. There's also kind of, if you feel like it, you can feel free to generalize your implementation to a kind of an arbitrary data flow framework that can solve any problem, and to parameterize it so you can feed in several different definitions of data flow analyses. I highly encourage you, however, that in the first phase of your implementation, you just make it work for one. Don't try to overgeneralize as a first step. Just try to make it work once, and then if you have extra time and you're super excited, then you can generalize out from there. It's not that hard once you've done it once, but I really don't recommend trying to get the fully general thing right before you pick a particular data flow analysis you want to run. So for example, I have a few test programs in here. It doesn't really matter what they do, but here's a factorial implementation. I can show off real quick what it looks like to run a simple data flow analysis on this. I need to, as usual, Brill to JSON this thing. And then I will pipe that into my generic data flow solver program, and then it has a few analyses built into it. One simple one is the defined variables analysis. This is just a super simple analysis that it's even more basic than live variables that are guaranteed to be used again in the future. Defined variables just like all the variables that have been written to at some point in the past at this point. And this is the sets of live variables at the beginning and ending of every basic block as labeled in the control flow graph. You are free to use this defined variables thing as kind of a warm-up. I think it's like maybe a little too ambitious for the actual thing that you turn in. A little too unambitious. I hope I said that correctly. But you can do all sorts of other things. Like, for example, you can find the live variables I've implemented in mine, or I've also done a simple constant propagation analysis for using my data flow framework. And the way that you can interpret this output is that every variable is marked as with a question mark. If I don't know what the value is, that is, if it's not a constant, if I can't prove it to be a constant at this point. And then maybe unsurprisingly, there's a variable called 1 that is guaranteed to hold 1 at every point in the program, and the same thing with a variable called 0. Anyway, go crazy, come up with whatever data flow analysis you want. Just scale it to the time you have available, implement some data flow analysis, and then take it as far as you like. You can implement a fully general framework and 100 different data flow analyses if you really feel like it. I want to show you just one small Turnt trick that you can use when you are testing this, which is that, as you might imagine, it might make sense to sort of set up Turnt tests so you can validate that, for example, this fact analysis does what I want. If you use the args functionality of Turnt, you can see that I've set up the you can see that I've set up the command for my Turnt setup to pass in arbitrary arguments to my data flow analysis. So if you want to run multiple data flow analyses and you also want to do this thing where you pass the name of the analysis on the command line, you can do that too. And you can specify in the file which data flow analysis you want to use, but Turnt also has an args flag. So we're in this verbose print mode, and we can also say, for example, use the analysis live or defined, for example, on this this program, and then I don't have to remember the whole pipeline every single time, and makes it really easy to run multiple data flow analyses on the same program if you set up your analysis this way. Good luck, and be sure to ask questions in the Zulip thread associated with this lesson.